So we're going to do the final topic today, and that's organic analysis, and then we're going to do spectroscopy. So, organic analysis, this is really a summary of all the different tests that you've learned throughout the organic chemistry course. So we're just going to go through this, but the detail will all be in the individual videos as we've gone through. So the first thing, testing for functional groups. This is quite important for organic chemistry. So if you're given an unknown organic compound, and they say what functional groups are in it, you can do these tests to give you clues as to what, whether it's an alkene, whether it's perhaps a halogen or alkane, what actual type of organic compound do you have. So, first test is for how do we test for an alkene. This one you should know from GCSE. You shake it with bromine water. It goes from orange to colourless. Now it's really important you put colourless, not clear. It's colourless. Clear just means you can see through it. You can see through an orange solution. It's colourless. It's lost all its colour. Hopefully that's clear. And what any information other further, this is the electrophilic addition of bromine across the double bond. So if it was ethene, you would be making 1,2-dibromoethane as the product. Halogen or alkanes, how do we test for these boys? Okay, well, this one you add sodium hydroxide solution. The sodium hydroxide the hydroxide will substitute the halogen atom and you'll get a halide ion coming out in solution. You acidify with nitric acid. That just gets rid of any carbonates or so on that may be knocking around. And then you add silver nitrate solution and you will see a precipitate. So, if you see a white precipitate at that stage, you know your halogen alkane would have been a chloro one. If you see a cream precipitate, it would have been bromo. If you see a pale yellow precipitate, it would have been an iodo halogen alkane. So, what are these tests? The first one, this one is a nucleophilic substitution, and then when you add your silver nitrate, it's a precipitation reactions. The details of that will be on the group 7 chemistry that we've looked at. Remember, it's difficult to tell the difference sometimes between a white precipitate, a cream precipitate, and a pale yellow precipitate, so we use ammonia solution to differentiate between those. Silver chloride will dissolve in dilute ammonia solution. Silver bromide dissolves in concentrated ammonia solution, and silver iodide is insoluble in concentrated ammonia solution. So you need to know those ones as well. Alcohols, how do we tell alcohols? Well, if you've got a primary or secondary alcohol, both primary and secondary alcohols can be oxidized. So you add acidified potassium dichromate solution and you reflux, and it will go from orange to green. You've just got to be careful here because aldehydes can also be oxidized. When we did the chemistry of alcohols, remember a primary alcohol will go to an aldehyde, and an aldehyde can be oxidized to a carboxylic acid. So an aldehyde would also be oxidized. You would see that change from orange to green. But if in the question they say you've got an alcohol, is it primary, secondary or tertiary? Well, your first test that you could do would be add potassium dichromate. If it's primary or secondary, you would see a reflux. It would go from orange to green. If it's tertiary, it would not be oxidized, so you wouldn't see any change at all. Okay, and remember, primary alcohols go to aldehydes and carboxylic acids when you oxidize them. Secondary alcohols will give you a ketone. Right, so aldehydes, how do you test for these? Well, there are 2 tests that we looked at. One was Fehling's solution, the other was Tollen's solution. Fehling's gives you a blue colour to a red precipitate. Tollen's gives you a silver mirror. And we looked in details of those. What are they? It's similar to the alcohols. Aldehydes can be oxidised, which we've just spoken about. Aldehydes can be oxidised to carboxylic acids. Remember, ketones can't. So if they say you've got an aldehyde and a ketone, which one is it? You could add either of these 2, and this would tell you which one you've got. And finally, a carboxylic acid. This catches people out because you don't remember carboxylic acid is actually an acid. Acids will react with sodium hydrogen carbonate. solution. So a carboxylic acid is only a weak acid, but it will react with sodium hydrogen carbonate. If you add that in, carbonates react with acids to give you carbon dioxide gas, you see bubbles. So what would you see? You see bubbles because you're producing carbon dioxide gas, and that is the acid plus carbonates reaction. So an acid plus a carbonate or an acid plus a hydrogen carbonate gives you a salt plus water plus carbon dioxide. So remember, you need to remember that from your acids chemistry that you would have done earlier in the AS course. Okay.